Okay, so today, it's working. We're going to go over those multiple choice questions. There are 17 multiple choice questions with the calculator, although a lot of those questions the calculator doesn't even help you, right? Oh, okay, well, I'm going to come around and see how far you got with that. But now, guys, in addition to these multiple choice questions, which will give you half the points for the entire test, will give you 54 points. You get another 54 points from the free response questions. And there are basic, you're going to have 6 questions, so 9 points each. And sometimes they have a weird question in there, but I will tell you there are 6 major topics that they like to test on the free response. Differential equations, area and volume, the graph of f prime, you're looking at a graph of the derivative, motion problems, like usually they give you velocity somehow, because it's in the middle of acceleration and position. Rate problems, like sometimes rate in, rate out, sometimes just a rate, and table problems. And I'm going to spend a little time focusing on each one of these. And tonight, your homework is just going to be on differential equations because that's most recent. I think it won't take much to refresh your memory. And in fact, for the do now, what I want you to do is just a little matching exercise. It's like if you're given the derivative, bless you, the derivative of a function, so this is a differential equation, is equal to f of x times g of y. I want you to match each of the following tasks to the appropriate action plan, like what you would do. Okay, there is one little correction I have to make, and that's on f, the last line, that should be a greater than. If the very last line, I think yours says less than twice. Okay, so you try doing that. I'll come around. All right, let's see if we can match these up. All right, where's my first task? Draw a slope field at specific points. Yay. Each point. Yes. Yes. You would plug in the x and y coordinates. Draw a little segment with that slope. Nice. 2. Write the equation of the tangent to the graph of y at the point AB. Hey, there it is, y minus b. This is just the differential equation. That's just what the derivative was equal to. When you plug in the a for the x and the b for the y. That's my thing. That's correct. Nice job. 3. Use the tangent line equation to approximate the function. C. Right, you're going to plug that value c in there. Okay, equation of tangent line. 4. Find the second derivative. How would you do that? C. Take the derivative of both sides of the differential equation, and anywhere you'd have a dy dx, and then replace it with what its equivalent, f of x g of y. So you guys were right so far. But you could still mess up, right? 2 left. You could get them both wrong. Let's see. 5. Determine if the linear approximation is less than or greater than the actual. F. Right, I guess you're getting it. You could still mess up. You could say one of the other ones. Solve the differential equation. No, just trying to make this more challenging. Yeah, you got to separate the x's and the y's. Integrate, putting the plus c on the x side, solve for c, and then solve for y. Okay. So that's pretty fresh, so I think you guys are pretty good with that. But let's get to, before we get to differential equations, free response questions, I want to go over a bunch of these. Not that. Okay, you tell me, look over the answers, look over your work. We're going to try to hit, do you need a copy of it? You have it? Okay, do you want to just borrow one for today? You don't need the calculator on too many of them. It's a little disappointing. Which one? We want to start right out with 92, the hardest question on here? We can. Well, we'll start out with a couple of, I promise you we'll do 92. We don't want to scare the kids, you know. All right, So 85, is that scary? I know. Oh, okay. So in question 85, they give us a little chart here of values. And they ask us for the definite integral from -4 to -1 of f prime of x. So the first step to evaluate a definite integral is take the antiderivative. What's the antiderivative of f prime of x? F of x, right? So we have to get the antiderivative of f of x, and we have to evaluate it from -4 to -1. So we're going to plug in the -1, plug in the -4 in that order, and subtract. And once we do that, f of -1, I just use the chart, that's -1.5. And then minus of -4, so minus 0.75. And that's how you get a value of -2.25. Good stuff? That was fun, right? It's enjoyable. You're mad you didn't say it? Yeah, I know. Now you're looking at saying, oh, I can't believe I didn't get that one. Oh, first time you see these things, it all looks mysterious. Somebody said today, it's like it's a different thing. I'll learn that language in a month. Okay, next question. Jessica, 81. This better be good. Oh. Oh my goodness. I'm glad you asked this one. This is something that they will definitely ask you, especially on the calculator section. I know in this one they've asked it twice, basically. They give you a point on a function, they give you the derivative of the function, and they ask you for the y value somewhere else. Now you have to make sure you understand this, because it's not obvious that that one is the derivative of the other. They say g is an antiderivative for f. So f is the derivative of g. Okay? So you're given the derivative of g. You're given a point on the graph of g. You're given that when x is 2, g of 2 is -7. And you want g of 4. So if you want g of 4, you start with g of 2, and you add the change. The way you get the change in a function is by integrating its derivative from the old x2 to the new x4. Does this look familiar to you at all? Yeah, this comes up a lot. Yeah, a couple. And then, so g of 2 is the -7. So that's where I don't want that. And then the rest, they didn't do anything to it. So they just left it, and this is answer E. Oh, because it doesn't matter. As long as you keep the same differential, you can call it whatever you want. Oh, that 3. See, I didn't even notice that. I don't know if that bothered you. Yeah. Okay. 87. You like that? These are actually much quicker than the other ones, I think, to explain anyway. Oh, 87. Why was I going to say something? 87. Now this, oh, this you could it's great that you just asked this one right after the other one. You see, this is coming into play again. They give you the velocity, which is the derivative of position. They tell you that the position at time 0 is 2. Bless you. And they want the position at time 3. So if you want the position at time 3, you take the position at time 0 and add the change. You get the change by integrating the derivative. Very important, when you use a plus here, the lower limit of integration is the same as in this case, the time where you started. These values match. For the kids at home, this, and this is a plus. And you're setting this up. What's that? Yes. Okay, normally I would say you can integrate velocity and figure out plus c. You cannot integrate velocity, because if you try to do u substitution, you don't have a t for the du. So the only way you could get this answer is with a calculator. Either it's impossible to integrate 1 plus t squared to the 1/3 without a calculator. It's not that you just don't know how, because you can't just use the power rule if you don't have du. It's not, you can't, integrate u to the 1/3 with du. You need a t for du. Okay? So yeah, that's why they love to put these on the calculator section. And so yeah, don't take the integral yourself on the calculator section. Yes. Sure. 89. What they tell us is in 89 is you've got a continuous function, and at -2 and 2, the y coordinate 0. So all you know is that at -2 and 2, oops, here we go, the y coordinate 0. You don't know what it looks like, but it's continuous. So you have to get from this 0 to that 0 without lifting your pen off the paper. Right? Now, just because it's continuous, it doesn't mean it's differentiable. There could be corners or cusps, things like that going on. It just means continuous, you're not lifting your pen off the paper. Then they say, okay, so it's continuous, the endpoints are zeros, and yet there's no value c between -2 and 2 at which the derivative, the slope of the tangent, 0. Normally, the slope of the tangent will equal the average rate of change. This is Rolle's theorem. As long as the function's differentiable. As long as it's smooth, somewhere between two zeros, the slope has to be 0. It's got to turn around to get back up here. Okay, that's what Rolle's theorem says. Is that as long as your function is continuous and differentiable, between any two zeros, the slope will be 0. But they're saying here, there is no value of x where the slope's going to be 0. So that's got to mean it's not differentiable. There's got to be a corner or something in there. And so that's what this is saying. So that must mean that for some value k between -2 and 2, the derivative doesn't exist. So there's got to be a corner in there. So there's no place in here where the slope is ever 0. It goes from a negative to a positive or something like that. Yeah. Yeah, but the thing is here is that they're saying there's no value c between them where the derivative is 0. Why would that have to be true? Because there's some value k, it doesn't have to be the same. You wouldn't want to use that value. You wouldn't want to use the same name. There's some value k where there's got to be a corner or something. Okay, you had said 89 and 90, right? 90 is a thinking man's question. Okay, let's look at what they gave us. Because when I'm going around the room, I think Riley had said, like, they didn't give you any. They didn't tell you what this function was. They just gave you basically 3 points, right? 3 points on a graph. And this is what they give us. They say, okay, the function's continuous from 2 to 4. It's twice differentiable, so it's nice and smooth, no corners. And the derivative, if the derivative at 3 is 2, the slope of the tangent is 2, and the second derivative is negative on the open interval. The second derivative is negative. There's our first big clue. Because when someone tells you the second derivative is negative, what do you think immediately about the function? It's concave down. So you know that this graph has got to be concave down. And what do you know about the first derivative? The function's concave down. The first derivative, it would be decreasing. So just from this one clue that says the second derivative is negative, we know the function is concave down, and those slopes have to be decreasing. Now, luckily, with all these little tables that they've given us, if we get the average slope between the first 2 points and the second 2 points, change of y's over change of x's is always 1. So if you look at the first 3 points here on this first graph, the slope between the first 2 points change of y's over change of x's would be 2.5. Now, and that's only, an average rate of change between the first 2 points. There's basically what you've got 2.5. So when you just found out that the slope between the first 2 points is 2.5, and then the slope between the next 2 points is 1.5. You see what I'm doing here? Now, I know you're probably saying, well, there's a whole bunch of points in between, but at least this is consistent with the fact that the slopes are decreasing. Okay, because this is so if you know the slope between this point and this point is 2.5, somewhere between there, the slope actually is 2.5. And then the slopes go to 1.5. So these slopes are decreasing. And then if you look at, so first thing I think I would check out is, well, let's make sure the slopes are decreasing. Yeah. Okay. Okay. So that's definitely in because the slopes are decreasing. We see that? The slopes are going from 2 to 1.5. And here they're decreasing. We can definitely rule out the last two because the slopes aren't decreasing. This goes 2, 2. That's not decreasing. 1.5, 2.5. That's not decreasing. So now the question is, why wouldn't it be C? Well, now we got to look at that other piece of information that they gave us. So we're down to either A, B, or C. They tell us that the derivative at 3 is 2. So let me just go to a clean page here for a second. 2, 3, 4. For that choice C, I just want to really kind of blow this up. Let's see. Could you tell me, for choice C, what y is when x is 2? 3? And then what y is when x is 3? And then at 4? Okay. All right. It's a squiggly there. I just try that again. Okay. Now, here's the thing. We found that the slope between these 2 points was 2, right? And the slope between these 2 points was 1.5. But the mean value theorem says that there's got to be a place somewhere between the first 2 points where the slope of the curve actually is 2. See, that's the average rate of change if I draw a straight line. The actual curve is going like this. Right? So if the slope is not 2 at 3, the slope of the secant would be 2 in here, which tells you there's a value of x between 2 and 3 where the slope of the tangent equals 3. Okay? Mean value theorem guarantees there's some place between 2 and 3, some x value, where the slope of the tangent actually is the same as the slope of the secant, be 3. Now think about it. These slopes are decreasing. So if the slope is already 3 at, is it 2 or 3? I'm sorry. I think I meant to say 2. I'm sorry. Okay. The slope between these 2 points is 2. If the slope is already 2 at some point between 2 and 3, and it's decreasing, constantly decreasing, there's no way it can be 2 by the time it gets to 3. Because it's going to be 2 somewhere between 2 and 3. That's what the average rate of change was between the points, the first point at x equals 2 and the second point at x equals 3. So that's why it can't be this one, because the slopes are decreasing, and we already know that the slope would have to be 2 somewhere in between 2 and 3, because that's the average rate of change on that interval. So let's look back at the other two. These slopes are going between 2.5 and 2. Okay, so that means that the slope was already 2.5 for some value of x between 2 and 3. And these slopes are decreasing. Could it be 2 at 3? So we've got to look at these two cases. We're looking at which one of these could the slope right at 3 be 2. Okay. Oh, see, the reason this one's not going to be good is because the average rate of change is 2 between the second 2 points, which means the actual slope of the tangent would have to be 2 at some value of x between 3 and 4. It couldn't be at 3. At 3, it'd be greater. So this is the only one. This is a tough question, but because this tells us there's a point between 2 and 3 where the slope's 2.5, and there's a point between 3 and 4 where the slope's 1.5. Well, yeah, at 3 it could be 2. That's right in there. So A is the best choice in this one. I just guessed that one right. No, you're not. See, this is what this is based on. This is the mean value theorem. That it guarantees you that the slope of the tangent has to equal the average rate of change somewhere between an x value of 2 and 3. Okay, so if it has to be 2.5 somewhere between these x's, and the slope of the tangent has to be 1.5 in between an x value of 3 and 4, and those slopes are always decreasing, it's possible that it could be 2 right at 3. Yeah, and B it couldn't be because it's going to be 2 between at an x value between 3 and 4. It's not like you could go back down to that. It's got to be decreasing the whole time. So yeah, there's a lot going on in that one. Okay, next question. We'll do 92. Let's do 92. 92 is going to seem like a breeze now. Okay, so when you looked at 92, be honest, you said we never learned about no rivers or cities. I'm not doing that. Did you say that? All right, so let's take a look at this. A city located beside a river. Here's the river. Has a rectangular boundary as shown in the figure above. The population density of the city at any point along a strip X miles from the river's edge. Okay, so here's the river's edge, and they're saying that the population density of the city at any point along a strip X miles from the river's edge. So how should I draw this strip? Do I want to draw a vertical strip or a horizontal strip? It's got to be X miles away from the river's edge. So let's say here's the river's edge. If I go at X miles, I want to have a strip. All right? So you want to draw a strip this way because they're saying the population density at any point along a strip X miles away from the river's edge is f of x persons per square mile. So, yeah, persons. I don't know when you're supposed to say persons versus people. That's something you guys can find out and get back to me. Okay? Um, so let's think about what I would have to do to figure out how many people were in the strip. If we know that f of x, population density, is measured in persons per square mile, so I'll just say mile squared like that, what would you have to do to get the number of persons living in this strip here? Well, before we even integrate, just like in this one little strip, you've got the number of people per square mile. You want to get the number of people in that strip. Multiply by what? Square miles, the area, right? Okay, what would the area of this strip be? Well, what's the length of this dimension? 7. What's this dimension going to be? Well, this is x. This is going to be a very infinitely small change in x. It's dx. So it's dx times 7, or 7 times dx. The area of that one strip would be length times width, 7 times dx. Now that would only give us the number of people living in this single strip. We want to get all the people, so we'd want to add up all these. So we integrate. Now, what would be the limits of integration for x? We'd want x to start at 0 and go to 4. So we'd add all this up from 0 to 4. And that, you can pull the 7 out. would give us the number of people in that rectangle living in that rectangular city. Cool? Always use the units. This would be, anytime you integrate, like when we got area, we thought y top minus y bottom times dx. Yeah, like that. What else, kids? Yes. Yeah. 83. He's got big questions. Yes. Speaking of area, that was a good little tie-in. Now, if you did not have, well, if you didn't have the calculator, it would be a pain because you're trying to find the total area enclosed by a cubic and a line. And if you had to do this without a calculator, you'd have to find out where they intersect. To get the area of this region, you would integrate y top minus y bottom. So it would be the cubic, blah, 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 minus what y equals on the linear, x plus 5 dx. And you would integrate from, I think it's 1 to 2, if these are right? And then you would have to get the area of the second region, blue, by adding up these rectangles. So by integrating from 2 to 3, now what's the y top going to be? For over here, it's y on the line, it'd be the x plus 5 minus y bottom is x on the cubic. So I'll just pretend I'm writing that all out there. And you would have two separate integrals, you would add them up, and you get all the area. Oh, 5. Thanks. Okay. So yeah, if you don't have a calculator, you'd have to do the two regions separately. You just do y top minus y bottom for each times dx and integrate. But here's the great thing when you have a calculator. You can get away with one integral, just add these up from 1 to 5. If you integrate the absolute value of either one of them minus the other. I chose the cubic minus what y equals on the line. Because whenever that goes negative, it's going to make it positive. So you're going to be fine if you just take one of them minus the other. As long as you put absolute values around them. You don't have to do two separate integrals. So you'd use your math 9, the absolute value just make sure you have parentheses around one of them when you're subtracting from 1 to 5. And you should get whatever answer is on the answer key. Right? Is that what it is, really? Sure. That sounds good. 88. Love it. 88. Let's see what this says. The radius of a sphere is decreasing at a rate of 2 centimeters per second. That's your drdt. Did you recognize that was drdt? Okay. It's -2. At the instant when the radius is 3, so when r equals 3, what is the rate of change in square centimeters per second of the surface area of the sphere? So what's the rate of change of the surface area? They're asking us for the derivative of the surface area. They called surface area S. So they're asking us for ds dt when r equals 3. So they give you dr dt, they want ds dt. This is a related rates problem. They give you one derivative, they want another. All you need is an equation that has an r in it and an s in it that relates the quantities, which they gave you. They gave you the surface area of a sphere. So once you have your formula, you take the derivative of each side with respect to t and plug and chug. So when you take the derivative of s, you get ds dt. When you take the derivative of the other side with respect to t, you get 8 pi r dr dt. So you get your formula, you differentiate with respect to t, and then you plug in the -2 for the dr dt, 3 for the r, You multiply them together, and you get your answer for dsdt, which is like negative 72 pi squared centimeters per second. It's a good one, right? If it's not a t, you can't forget its derivative. Anybody else, if you're taking derivative with respect to t. Other questions in here? All right. All right, then what I want you to do is take a look at these free response questions I want you to try. Now remember, they're worth 9 points each. I always warn kids about these problems. I think these are the easiest ones to get, but let's take a look at this first one. Yeah, we got a few minutes. So they give you a differential equation. B is the bird's weight, T is time. So dB dt, that's the change, that's the rate at which the bird's weight is changing. Okay? Change in bird's weight per change of time. And they tell you what it equals. The first question, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? How would I figure out? Yeah, because this is already giving you the rate of change. So you're going to plug in the 40 and the 70 and see which gives you a bigger value. Okay? So that you don't have to do anything big for. Here's the part that I really want to emphasize here. They ask you to find the second derivative with respect to t. Remember, in a differential equation, they've already given you the first derivative. Find the second derivative with respect to t in terms of b. Okay? I like to do that with you. So to get the second derivative with a differential equation, what do? Now that's to solve it. Yes. Yeah, take the derivative of both sides. Perfect. So you take the derivative of this side with respect to t, you get the second derivative. Now this is where I want you to be careful. Take the derivative of the other side. Like the 1/5 we can leave out. It's a constant multiplier. Is the derivative of 100 minus b just minus 1? I'm taking the derivative with respect to t. So what is the derivative of 100 minus b? Negative b dt. Okay, so it's negative 1, but then times dB dt. Because it's not t. If it was 100 minus t and we took the derivative with respect to t, it would just be minus 1. But if it's any other variable, think of the chain rule. Like when you take the derivative of x, it's 1. If you take the derivative of x with respect to x, if you take the derivative of y with respect to x, it's dy dx. Okay? This is the derivative of b, but not with respect to b, it's with respect to t. Now, when you get the second derivative, remember you take the derivative of the first derivative, we don't leave the dB dt there, right? We're going to replace it with the 1/5 100 minus b. So we have the 1/5 times negative dB dt will be negative 1/5 times 1/5 times 100 minus b. I would make it minus 1/25 100 minus b, but you could leave it like that. That's just arithmetic. I can't tell you how many people get that part wrong when they get the second derivative of a differential equation. Just be careful. Oh, all right. You're going to use that to explain why that can't be the graph. We replace dB dt with that. That's what you want to do when you get a second derivative with the differential equation problem. Try your best with these, guys. Try your best with these homework problems. Oh, I didn't even tell you guys. On Friday, the test is going to be a replacement test based on the 2008